Good afternoon, everybody. Evening, almost. My name is Gary Russell. I'm the project lead for the Spring Integration project. I also lead the Spring AMQP project, which is our Spring abstraction on top of the RabbitMQ Java client. Before we get started, does anybody here not use Spring Integration or haven't seen Spring Integration yet? Some, okay. For those of you that are you all using XML right now, or have you looked at using Java config or using the DSL to do your flow configuration? Okay, so some have looked, some haven't. So was anybody at Spring 1 last year? Wow, welcome back. So some of this will be a little bit of a recap for you. So what I'm going to try and do is quickly spin through what I did at Spring 1 in September, which basically took us a progression through from a pure XML to a Java DSL configured application. And then I'm going to spend a bit of time going through just showing some of the test cases in the project, which is a good exhibition of how to use the DSL. And we're going to just do a little bit of background, dig into exactly what the DSL does and how it works and where we go from where we're going next. Just a few links here. These are the only two slides I've got, the title and this one. For those of you completely new to Spring Integration, it's a canonical implementation of the enterprise integration patterns. The book by Gregor Hope and Bobby Wolf from probably a decade or so ago now. Mark Fisher instigated the project, I think a little over 5 years, maybe 6 years ago now, and basically it's providing a mechanism or tooling to do integration of your enterprise applications to assist in those in that work. So a few links: the project page, Spring IO projects integration. We typically keep a what's new in the top of the reference guide, so that's a good thing to look at. All the stuff I'm going to show in the presentation today is on GitHub in the samples repo, and of course there's the actual Java DSL repo itself. So that being said, I'm going to, as I said, start off with the project, and if I just go to GitHub, hopefully I have signed on here recently. It's not going to. The samples repo, Spring Integration samples, and this particular project is in the so the samples are broken down into basic samples, advanced, intermediate, and then we have this new section DSL where we have some DSL samples, and the primary one we're going to look at today is this SI4 demo, because this started out in a webinar early last year where we first introduced Spring Integration 4.0, and as I mentioned, the Spring 1 talk took us through starting with a simple XML-based application, and I'm going to bring that first one up now. Simply, all this flow does is we start with a messaging gateway. For those of you not familiar with Spring Integration, messaging gateway is a way to get messages in and out of the messaging system without your application code knowing about it. So Spring Integration with a gateway, you provide it with an interface. In this case, it's this foo service interface, and you invoke that interface. Spring Integration builds a proxy for you and the implementation of that interface. In this particular case, we start with a gateway. We have this channel called foo that's then routed to a transformer, and all this transformer does, it's a simple spell expression-based transformer that concatenates the payload with itself. It's a simple string payload, so we just concatenate it with itself. The next step in the flow is a simple uppercase operation on that payload. And because there's no output channel on this service activator, the framework it inspects the message and says, oh, there's a reply channel in this message that was actually set up when the message arrived at the gateway, and the result of that goes back to the application. From a Java perspective, typical Spring, we start up with the application context, and all we do is this is the interface that I mentioned that we invoked, and all we're doing is invoking that service, and as you can see, we pass in foo, and we get back foo, and if I run that, I'm not going to go through, as I said, I'm not going to go through the whole thing we did at Spring 1, but this flow, as I said, concatenates foo with itself and then uppercases it, and so we should get console, so now we get foo. You can see, so concatenated and uppercase the payload. Pretty simple. So that was how we started out with the demonstration. We then go through a few iterations of that. We started out with using annotations. These annotation-based transformers and services were available as of Spring Integration 2.0, and it was usable, but not very. You had to tie your application, your Java classes, back to your XML, and it just really wasn't very intuitive. So we then went on to Spring Integration 4.0, which introduced a couple of things. One is that you can now annotate at bean definitions. So those of you that don't know Java config, the equivalent of an XML bean in angles is an at bean annotation, and we can now annotate beans with the messaging annotations. So we effectively provide a mechanism now where you can fully define your Spring Integration flow without any XML at all, and that's what this third example was. So what we can see now is effectively we have the same application. It's sending foo in there. We have this messaging gateway annotation on the interface. As I'm sure you're all aware, the no Spring in detail, the sort of Spring can do component scans for beans, but it doesn't find interfaces. So this is a specific Spring integration annotation that goes on the interface, and it does exactly the same thing as what I had in the XML config. This in gateway XML definition is replaced by this messaging gateway annotation. So the framework detects this annotation on an interface, builds the code behind it. So when in this test code here, where we're sending a message, when we're invoking this foo method on the foo service interface, the framework takes that payload, this foo, constructs a message around it, makes the payload, makes the foo string, the payload of the message, adds headers, reply channels, and all that good stuff, and then the message flows through as before. So we have this foo channel linked to the transformer that did the concatenation, and then we did the uppercase stuff as well. So effectively through a couple of helper classes. So that was a good step forward, but it still was not. It didn't really satisfy the need to have a fluent Java API to build a flow for the application. So. And as I said, we went through, so no XML at all. Then we introduced Spring Boot, which makes life a lot easier because it does a lot of auto configuration. So with Spring Boot auto config, you can automatically configure things like Rabbit and other components that we're using. And then ultimately we ended up with at the end of the Spring 1 talk with this mail flow. So let's look at this in a little bit more detail. So now this is actually using the Java DSL. Let's get rid of these white space markers. Again, we have our main method that's just it's just calling this service foo. Again, we have this messaging gateway. So again, just simply we have an interface that we annotate with messaging gateway. That then provides an abstraction over the messaging system. The application code only interacts with that that gateway interface. And here's now the sort of first thing we're going to see from the DSL perspective. So we're using Java 8 lambdas. The DSL doesn't require lambdas, but I'll be quite honest, it's richer when you use Java 8 and lambdas because we don't have a whole bunch of anonymous inner classes defined. But here's the flow. So in this case, we start with a lambda. The flow, the initial method is a transform, which is doing just what we did in the XML, where we're concatenating it with itself. Now we're using a lambda and we're going to return a string. We're going to basically do an uppercase transformation on it. And now we're actually going to send it, we use this route recipients DSL method, which is going to send it to two recipients. I called one a bridge to nowhere. So this is a sort of a colloquialism within Spring Integration. What we typically do, as I mentioned before, when a message arrives at a component that has no output channel, then the framework looks at the message header and says, oh, okay, I need to route where am I going to route this reply to, looks in the headers and said, okay, there's a reply channel, so it goes back to the gateway. So a typical scenario for that is, in this case, we want to send it to two places. We want to send the reply back to the gateway, but I'm also, in this case, I'm going to send it to Gmail. So I'm going to send them a copy of this message to Gmail. So the first copy, so it's a recipient list router. We're going to send a copy to this bridge, and then the second copy goes to the SMTP channel. And the SMTP channel is the input channel for another flow that's defined in this class. In this case, we're beginning it instead of using a lambda. The difference here, where I'm using a lambda here, there's a sort of default input channel when you're using a lambda. Here, in this case, the channel would be foo.input. That's the name of the channel. For the SMTP, I've actually explicitly defined that this message is going to come from the flow is going to start with the SMTP channel. We use the header enricher to do things like set up the subject, the to and the from in the email, and now we have this generic handle method that any message handler can then receive the message. The DSL is not complete yet in that we don't have full first-class support for every integration component. So we don't have JDBC yet, for example, but we have JMS, a Rabbit, MQP, Mail. And when I say first-class, you can still send messages to handlers that don't yet have first-class support, but the syntax is a little more involved. In this case, we do have first-class support, so we've got this mail factory that has a static method outbound adapter. It's going to create this outbound adapter with this URL and port and la-di-la-di-la. I got some credentials. This is showing off some boot goodness. Anybody familiar with boot or have looked at boot? So it's actually using this Gmail properties class, and what that does is that's a configuration properties from a Spring Boot perspective, and what it does is it will automatically find properties on the class path. Now, in this particular case, we have in the application YAML. Of course, I'm not going to show you all my passwords and stuff here. I have another copy of this file on the class path, but this is using YAML. So in this case, Gmail user password is gmail.user and gmail.password are the credentials that we're going to use to talk to Gmail. So then the Gmail properties class is automatically populated with those properties using this Gmail prefix. So back to my class here. So we have the Gmail properties. We're configuring the mail outbound adapter. We can do things like set up the Java mail properties. In this case, I'm just turning on debug, mail debug. Now you'll notice here that the outbound adapter, the handle method really has two parameters. The first is the message handler, and the second is the endpoint. Just to take a step back, in Spring Integration, every component is known as an endpoint. We have inbound endpoints, outbound endpoints, or mid-flow endpoints, and anything that's consuming, so a service activator, a transformer, or an outbound gateway channel adapter, consists of two actual beans. There are two beans involved from a pure Spring perspective. The XML parser creates those two beans and wires them together. The two beans are a message handler that actually handles the message and takes some action on the message, and then the endpoint itself, which depends on the type of channel that the message is going to arrive on. So we have things like, we have an event-driven consumer, we have a polling consumer, depending on that channel type. So in this case, the two arguments to the handle method are the message handler and then the endpoint. And in this case, we've just given it an ID, but we can also have, there are other methods on it, such as auto startup, right? So we can set that to false, say we don't want this endpoint to start automatically, things like that. So one of the really nice things about using the DSL in an IDE is you get all this context assist for while you're building your flow. So what this, as I said, what this flow does is sends a message, does a little bit of transformation on it, returns a copy to the sender, and then sends a copy out using the mail, the SMTP outbound adapter. So if I run that, let's see. While that's cooking, oh, it's running. Okay. So it's a Spring Boot app, and we should see the foo-foo shortly. There we go. So that was the. Remember, I said we're sending two. Went to a recipient list. One went back to the sender, which is just our system out print line. The other one went to mail. So to see that, the final example in the Spring 1 talk was this was the IMAP the IMAP mail adapter. Let's make the screen bigger, which is basically just a simple IMAP idle flow. It's using an IMAP idle inbound channel adapter configured with the URLs and stuff. And in this case, we're just doing some things like getting the headers and adding them to Spring Integration. Out of the MIME message, which is the payload, and adding them to the headers, so subject and from. Doing a bit of transforming on it, and then all I'm doing is printing out the mail. So this is basically receiving the mail that was sent, that we just sent a few minutes ago. And there we go. So this is that email message that that we just sent. So one of the things that hopefully that makes it clear, useful to see, is that it's very easy to write integration applications just by assembling the flow together. Things like sending email, sending messages to JMS, sending messages or receiving messages from Rabbit. It's all done with this sort of declarative programming style. And the framework takes care of most of the boilerplate code for you. I mentioned about projects that don't yet have, or components of Spring integration that don't yet have full support, and so I can actually quickly show. We have in the same project in the samples. This is a Twitter. So this is basically doing Twitter searches, and again, in this case, even though we don't have, we don't have Twitter dot make me a search adapter as a factory method. You can just define the Twitter search bean as a standalone bean, and then just invoke it from this handle method. So we're going to invoke TwitterGate. So this again, very simple application. The actual flow, there's a lot of beans. This particular application, you can interact with it over Telnet, you can interact with it over HTTP, but the error flow is pretty simple. We get a request in, we do some transformation on it, and in this case, it's only allowing searches for hashtags that begin with Spring. And as we can see, one of the options here on the filter is we can send the message to a discard channel. Otherwise, the message is then sent to this Twitter gateway. The result of invoking Twitter, we're going to get a number of tweets back, and in this particular case, we're just grabbing the first tweet from that returned list and converting it to JSON. So again, pretty simple, pretty straightforward integration flow using this Fluent API. And I can run that. And as we can see, we get back a tweet, and looks like somebody's tweeted that we can replace an ESB like mule. Okay, so again, simple application. If you go to the DSL sample app, you can explore that with some more in more detail. So that's really what I covered at Spring 1, and so that was really just a more of a recap in terms of how you go from an XML to a pure DSL configuration. Let me see. So let's go look at the actual DSL itself and see exactly what's a little bit more detail about how we can build these flows. Let's see. Let's see a good one. Okay, similar recipient list. So this particular test case here, I'd say a good place to explore the DSL is to take a look at all the test cases. A lot of the test cases are in this integration flow test, but as you can see, we have support for direct, currently first-class support for Rabbit, for events, for file system access, FTP. We do have some JDBC support, not stored procedures yet. That was the thing that I mentioned the other day. Mail, Mongo, and SFTP, of course. So one of the things that let me find that. Okay, there we go. Here's a simple integration flow that splits. So we have a collection of a message that has a payload that has a collection of objects in it. The split method will break that up into individual messages and send each one of them individually to this channel. Now, one of the things that may not have been obvious from before is that with the DSL, we don't have to put channels between each element. The framework will automatically wire these elements together with a direct channel. In this case, we have included a channel element because we wanted to turn this into we wanted to use an executor channel here. We didn't want to, we want to basically parallelize the handling of this split message. Is then doing a resequence on it and then an aggregate. But one of the things that as I said, that I'd really like to push here is the fact that we can, with our aggregator, using lambdas, of course, we can actually go ahead and set up things like the release strategy and all those good things. One thing I wanted to let me just go to log in here. Okay, so let me take you to the documentation. So Spring Integration Java DSL is the repo. The reference manual is here. It goes through a lot of examples, message channels. Here we have we can use obviously. Publish, subscribe channels, regular channels, direct channels. We can configure pollers, and one of what I'm trying to get to is the notion of subflows, because this is an interesting technique. Okay. In the XML world, when we have a router that routes to multiple destinations, they're separated in the XML file. With the router here now, we can actually add subflows directly into the route. So in this case, we're routing on whether the payload's even or odd, and as you can see here, within the subflow, he's actually multiplying even numbers by 2 and odd numbers by 3, and then they drop out of this flow. So the idea of a subflow is you can within a route, you route to the subflow. It's almost like invoking a content enricher, where you go out, you run a little bit of code, you come back, and then it drops back down into the main flow. So in this case, we split, we route, we depending on the routing condition, we run to one of these subflows or the other. Then when that returns, we then continue in the main flow through the through this flow. Yes.
So is that parallel, or is it?
Well, it can be. By default, not. But if in this case, if we add a channel and then we add an executor to it, so that then would make that parallelized. But it makes it succinct now. And so instead of in the sort of XML world, these subflows would be somewhere else in the file, whereas in here they're just inherent within the flow. Okay. The other thing I wanted to point you to is in the blogs we have a couple of examples of let's see, search. We have a line-by-line tutorial. Okay, so this has actually received some criticism, and I understand why, because it's actually quite complicated in terms of the way the example that was used. So going back to the GitHub repository that I mentioned before, we have the So in the Java sample, in Spring integration samples, under this DSL, this SI4 demo is the one I was going through before. The Cafe DSL, the canonical example, going back way back to the original project, we have this Cafe sample. The idea with a cafe is that we have a notion of an order comes into the cafe, we split the order into hot and cold drinks, and then they're handled by a barista, and then the order gets sent back to the channel. So what we did with the DSL was to take that cafe sample and rewrite it in the DSL. And the blog that I just referenced to takes us through that whole demo, and he basically goes through a line by line exactly how. And as you say, that this this DSL is pretty tough to read, right? I mean, it's so. This is sort of a value object lesson that it's not a panacea. You still need to, it's still a good idea, just like with any programming, to keep your flows small. But this wasn't really intended as this is the way you should write a DSL application. It was really trying to go through and explain line by line. So given this flow, in this case, we split the order. We use an executor channel to run, so they run in parallel. We route them to the hot and cold, and it's done with subflow mapping. So we route the hot messages and we route the cold messages, and then we end up with, coming out of that, we end up with drinks, and we aggregate them back into an order, and then they go back to the channel. But this is, as I said, I'm not suggesting you write a flow looking like this, but this is a good resource to go through. And as I said, he went through line by line and explained exactly how the DSL works and what's going on behind the scenes. One thing that that is a bit of a concern for some is that a lot of people are not ready to go to Java 8 yet, and they say, well, can I still use the DSL? Can I still take advantage of the DSL, but I'm only able to use Java 6 or Java 7? And so we republished, or we published a second version of the blog where we redid the DSL, we redid the cafe example, but this time not using Java 8 lambdas. And you can see it's a little bit more verbose, but in some ways it's better because now we have separated flows. So we've got the iced drink flow and we've got the hot drink flow as separate. And this is more what we want to do, what we should do, is go back and rework the lambda one to say, well, this is probably how you should do it rather than that. But it's a good for those of you that aren't ready to go to Java 8, and I was sort of, for the longest time, I didn't really see any compelling reason to go to Java 6 and Java 7, but the Lambda support, I don't know if anybody went to Venkat's talks earlier today, but the Lambda support in Java 8, to me, makes it, there's definitely a compelling reason to think about moving to Java 8. And hopefully, without that syntax that we just showed, that this is an illustration of that using lambdas really makes a very succinct definition of the flow. So that's another resource, is that those tutorials. If let me see. If you, let me see, let's see, spring one. I should have had these lined up before. All of the Spring 1, or certainly most of the Spring 1 from last year talks are now available on the YouTube channel. Actually, maybe that's where I should go to. Spring.io video. And so, if you want to go through that whole exercise that I did, where I went from XML to the DSL, that talk's up there. Let's see. Well, I'm going to try and find it now. IntelliJ. So we're a little bit ahead of time here. Is there anything anybody specifically wants to see in terms of DSL?
Question.
Yes.
Spring Full Suite, there is the ability to visualize the flow in the graph.
Mm-hmm.
Is the same thing available with DSL?
Unfortunately, not. In fact, the tooling is always a little high. If you go back to the old days when Spring Annotations came in, the bean graph didn't fully handle. So we're a little behind there. There is some work going on. I mean, sort of watch this space. I don't think it's going to be directly in STS, but we're working on some tooling that will provide actually a richer capability than you can currently get in the STS graph. The STS graph has got some limitations in that. Let me see if I can pull up. I have the samples in here. I don't have it. The STS graph only works on a single file, so if you've got imports and stuff, and and it's not really had a lot of time spent on it recently. So we're taking a different approach to actually, and in fact, there's a couple of things that we want to look at. One is to have a real-time view of the flow, not just a sort of static how I've defined it. So instead of introspecting your configuration or trying to read Java effectively to build that static graph, to actually look at the running context and be able to even provide things like hotspots and sort of, look at JMX, look at the counts and sort of turn components red if they're slow and things like that. So, I mean, I'm not making any promises there, but that's the areas that we're looking at for that. So, sorry, this one.
One is, can you load channels dynamically?
So there's a couple of things that that you can do. One is obviously you can always create any of these components programmatically. I mean, just in the DSL is doing a static definition, but just like we have those beans, I mean, you can create a Twitter outbound adapter on the fly. You can create and you can wire it into your application context. There are some other techniques. So, for example, there is a if I go back to the samples in the, I think it's in. It's in advanced. In the advanced sample, we have this dynamic FTP. And what this sample does is this came from I think it was back in the old Spring Forum days. It might have been Stack Overflow, but I think it was Spring Forums where somebody said, "I don't know my FTP destinations up front. I need to add them on the fly." So sorry. So basically, what this particular sample does is it implements a dynamic router, and what we did with the dynamic router, it's a dynamic channel resolver effectively, and it for each new FTP destination, it creates another application context, and then gets the channel from that and then routes to that channel. So it makes that channel visible to the main application context. That works fine. I mean, that actually works very well. So if you look at that, if you dig into that sample, there's a couple of things. So that the XML, this is like the mini, this is all it has defined in it is the channel, and it's not very big on front. Let's see. So it just has this channel, and then it has a configured, adapter, and then so back in the XML, it basically adds those properties to the context and fires up the new application context with those properties, sets the environment, and then that. Now it's not linked. It's not used directly in here. That's fine for an outbound adapter, right? Because all you need is a handle to the channel, and then you can route to it from the main application context. It's a little more tricky when you want something dynamic on the inbound side, right? So let's say you want to add, I don't know, a new TCP inbound adapter, but because child contexts can see things in the parent, but the parent can't see things in the child, so you would have to route to the channel. So I say, in this case, there's no there doesn't need to be a connection between the two between the two contexts, because we just get a reference from the channel from the mini context and use it in the main context. In the other way, we have to get a reference to the channel that's in the main context. So what we do there is we simply make the application context a child of the main context. So now, just like in a web application where the servlet context has access to beans in the root context, beans in the inbound adapter context can see the channel. So this example doesn't do it itself, but it does in the README. There's a link to a forum post where we went through that whole process with some users so they could dynamically add those inbound adapters. So that's pretty common.
I have one other question.
Yeah.
The enterprise integration patterns also another implementation.
Mm-hmm. So there's been obviously there's a lot of comparisons between the two. There's a number of people that like Camel. There's a number of people that people have preferences either way. I would say before the DSL, I mean the overriding complaint or thing that was cited by people said, I like Camel because, and it was because they have a Java DSL. I think we've gone a long way to address that now, and actually even more because of the use of lambdas, and I think it's actually a much more rich DSL than they have. So I think DZone did they did a paper at the end of last year. It was like just looking into enterprise integration solutions as a whole, and I think they said 42% of respondents use Spring Integration and 38% use Camel. So so I wouldn't say there's a whole lot. I mean, but it's just there's definitely it's right, horses for courses, whatever people are most comfortable with. Obviously, I prefer more people to fall in our camp, but I think the one thing that we've always said that is and it's a little bit. When you're using a DSL, you lose a little bit of this, but the one big plus for us, I think, is that the coupling between the components is looser with Spring Integration. So the fact that we have a channel, if we go back to that first XML that we looked at, where's the window? What was it? So the fact that we have this channel here as a first-class component in Camel, these things would all be squashed together. Now you can do that in Spring Integration. We have a thing called a chain where you can put multiple components together, where you want to consider that chain as being a black box. With Spring Integration, though, for testing, for example, you can, in your test cases, you can override this foo channel to be a queue channel instead of a direct channel. And so now you can consume from that in your test case and say, did I get that? Without actually impacting your main flow. So you can override, you can change that foo channel to an executed channel with just by configuration. Say a little bit, when using the DSL, you lose a little bit of that because you're now hardwiring stuff in Java. But if you separate your DSL components, at those points where you think you might want to make changes, then so that's always been, I think, a big plus for us is that is the fact that the channel is a first-class citizen. The channel between components is a first-class citizen. But now I think most of the complaints, most of the arguments for where the Camel camp was sort of basically had us beaten was we don't have a fluent API, a Java DSL, and I think this has gone a long way to solve that. Yes, sir.
Yeah, a follow-up question about the visualization series in IntelliJ. I think they have a plugin there, but I wonder if they're developing anything comparable.
To be honest, I'm actually in the transition. I'm sort of I keep flipping back and forth. I was always an STS Eclipse person, and we're doing some work with Scala, and that when I tried that in Eclipse, my Eclipse blew up. So I switched to IntelliJ, and then I'm really in a tough spot right now because there's things I like about each platform, and I'm not sure where I'm going to end up, but I do like some of the refactoring capabilities in IDEA. But from what I heard, I haven't looked at it, but from what I heard, that the graph support in IDEA is not very sophisticated. But they're always I guess trying to improve things. So they're always pretty good at supporting the Spring ecosystem. So who knows? Yes, sir.
Are the other DSLs, Scala and Groovy, at a similar level of maturity as far as their endpoint support, or do they all kind of track the same, or are they?
So it's actually interesting. The Scala DSL really hasn't had any TLC for quite some time. The guy that was working on it stopped working on it, and we're busy enough on the main framework without the. But we really felt that the Java DSL was something, because of this whole Camel thing, that we had to provide a solution to that. The Groovy DSL is kind of in a similar situation, and I think obviously if the community wants to contribute to it, then we're happy to take contributions. I don't think the core team specifically is gonna spend an awful lot of time on that at the moment. We really want to flesh out the Java DSL to get that complete. So I guess that's a sort of a non-answer, really. But yeah, they're not. I mean, well, you can see in GitHub, they've certainly not had a whole lot of activity on either one lately. Yes, sir.
Slightly off topic, but we've looked at combining kind of scheduling with some kind of integration, Camel or Spring integration. In the Spring world, is Quartz still kind of a scheduler, or is there what's the current state around what Spring recommends for scheduling, and RB is there any visualization for kind of like a scheduling console where you schedule jobs or you schedule jobs?
Yeah, I'm not sure if we do anything in the XD space, are we, Glenn? Well, I'm not sure we do anything in the scheduling space with XD.
The only thing that we've got on the scheduling is just basic cron support and for triggers.
Yeah.
There has been discussions including other things, but for right now it's just basic trigger that has cron and fixed delay feature.
Yeah, I'm not aware of any visualization. I think, yeah, most people use Quartz. We are looking at putting some more first-class support for Quartz in certainly into integration, because one of the things that we're getting a lot more interested in sort of a clustered environment. I mean, if anybody was at Spring 1 3 or 4 years ago, we do have it's really a sandbox. It was a proof of concept, and it's actually in use at least one big company where multiple instances of Spring integration application, but maybe they're pulling from a shared NFS folder, right? So you got file adapters. So you need some kind of a coordination between those instances. So we did come up with a solution for them where we actually manage. There's only one of those instances is live, and the others are sort of like warm standby, and we switch over to them. But what's really exciting from my perspective is the XD story, because Spring XD, if you're not familiar with it, is sort of an umbrella project that is, apart from being used for streaming big data, is that it's really become the sort of de facto way to build resilient Spring integration flows, because you can do just what I said. You can have one JMS consumer or file system consumer running, and if that crashes, the XD admin will detect that and fire up another instance, redeploy that instance somewhere else. So it uses Zookeeper as its coordination mechanism at the moment, and so that's actually. I think that's pretty exciting. The fact that we really have right out of the box, we have effectively resilient clustered Spring integration applications. In addition to that, it also has support for Spring Batch, so you can drop batch jobs into XD, and and it has full REST API. But as Glenn said, there's not really a built-in scheduler for there, and I'm not sure that we want to write a scheduler, but we want to provide mechanisms to.
We had early on. I even had Quartz on the backlog, but we kind of pushed it way down.
Right.
And that's because you can from Quartz have that coordination and kick off events into. But if there's a story or a business case you can give me, I can certainly talk to it, because I worked at Terracotta and worked with Quartz and working now at Spring doing XD. And if there's a case that you can give me, I can certainly see if I can get it bumped up on the backlog. But,
The other thing we've done a fair amount, some add-ons that we did really in the 4.1 is we now have persistent metadata stores. So things like the file adapters that persist. Have I seen this file? You can actually store that state in Redis or Gemfire or technology of your choice, and so that is another mechanism by when you got multiple instances, they can coordinate and say, okay, only I'm supposed to work on this particular element. Anything else? Oh, it's late. I was thinking I'd let you guys out. All right, thank you.